Let us look at a general case in finding the derivatives of implicit functions. Now, you have z across my z is equal to a function of x and y. Alright? Let u be g of x, y. So another function. G is another function. And then v is yet another function. H of x, y. Alright. Now we have a small change in u is equal to the partial derivative of u with respect to x times a small change in x plus the partial derivative of u with respect to y times a small change in y. We also have the partial derivative of v. A small change in v is equal to the partial derivative of v with respect to x times a small change in x plus the partial derivative of v with respect to y times a small change in y. Alright. Now, let's call this equation 1 and this equation 2. If we multiply, say, equation 1, let's multiply equation 1 by delta v by delta x and see what happens. Now, we multiply this by delta v, so we have delta u times del u times delta v by delta x is equal to, now this times delta v by delta x, so we have delta u by delta x, which we have up here, and delta v by delta x multiplied by a small change in x. Alright, so you see that? Plus, and then multiply all of this by delta v by delta x. So we have delta u by delta y, which is this, times delta v by delta x, which is this, right? And then we have our small change in y. So you see that? So we have equation 1 multiplied by delta v by delta x. Now we'll have equation 2 times delta u by delta x. So let's do that. The delta u by delta x here, we multiply this, so we have change in v times delta u by delta x, right, is equal to, alright, so we have our delta u by delta x times delta v by delta x, this time this, so delta u by delta x times delta v by delta x, and then we have our small change in x, alright, plus then delta u by delta x will multiply delta V by delta Y. So it's this times this now. So delta U by delta X, delta V by delta Y. Delta U by delta X, delta V by delta Y. See that? Times our change in Y. Okay. Now, here, notice we have delta U by delta X, delta U by delta X. We have our delta V by delta X and delta V by delta X. We have our delta X and our delta X. Right? So, essentially this and this, they are the same thing. So here now, we subtract equation 1 and 2. We could call this equation 3 and this equation 4. So we say equation 3 minus equation 4. Equation 3 minus equation 4. So we have delta U, I mean del U, change in U, times delta V by delta X minus change in V times change in V times, let me rewrite this change in V here. Change in V, alright, times delta U by delta X. So it's this minus this is equal to this minus this has gone. It's 0. You know it's 0 already. Right? This is equal to this minus this now. Delta U by delta Y, delta V by delta X, change in Y, minus delta U by delta X, delta V by delta Y, change in Y. You see that? But you see this change in Y, the del Y. You could just factor it out, right? You factorize and put it outside the bracket. Now, let's divide both sides by all of this here. If we divide both sides by it, what we're going to have is that the change in Y is equal to this, going to be change in U, delta V by delta X, minus change in V, delta U by delta X, all over going to be delta U by delta, let me rewrite the U part again, delta U by delta Y, delta V by delta X, minus delta U by delta X, delta V by delta Y. Alright, so that's what we have. So delta Y is that. Now, here, this, if we multiply both top and bottom, we have another way we could write it. If we multiply the top by -1 and the bottom by -1, could be written as change in V, delta U by delta X, minus change in U, delta V by delta X. So that we have them in somewhat alphabetical order, U first and then V. Right? So this is, so at the top it was V and then U. Let's put U and then V. U first then V. Alright, to make it more orderly, in alphabetical order, and more consistent. So this would become positive if we multiply this by -1. This had changed from negative to positive. This changed from positive to negative. Same thing with bottom here. This changed from negative to positive. This changed from positive to negative. So what we would have here is delta U by delta X, delta V by delta Y, minus delta U by delta Y, and then delta V by delta X. Alright, so we have this in order. U and then V, X and X, U, then X and Y. Alright, so that's what we have. Now, let's go back here. And this time, we're going to make a little change to it. We're going to multiply this part, the equation 1, by delta V by delta Y, and then equation 2 by delta U by delta Y, in order to eliminate delta Y and find delta X, because what we found a while ago, this is really delta Y. Let's make a little change. Let's erase this and put. Let's put delta Y one side now. Let's put this as delta Y. Let's copy it and put it one side. So we have delta Y is, I have delta alone here. Hold on. I have delta alone. It's delta V. I left off the V. Alright, so make sure just want to make sure everything is alright with it. I had left off the V from that delta. I have delta Y equal. So we have delta Y is equal to delta V times delta U by delta X minus delta U times delta V by delta X over delta U by delta X, delta V by delta Y minus delta V by delta X, delta U by delta Y. Alright, just to make sure everything is alright. So let's copy this. Let's put it one side here. I combined it already. Let's put it up here. And then we work out the other one. So erase. Erase. Let's erase from here going down. We're going to make some changes to it. By the way, a while ago we had multiplied by delta V by delta X to get the same del X and eliminate it to get del Y. Okay. Oh, let me erase this part too. Let's deal with this part now. Equation 2 by, let me write it here. Equation 2 will be multiplied by delta U by delta Y. Let's do that and see what happens. Delta U by delta Y, let's multiply delta V with it. So this is delta V times delta del V, times delta U by delta Y equals this times this now is going to be delta V by delta X times delta U by delta Y, small change in X, plus this will multiply this now. So delta v by delta y times delta u by delta y times small change in y. Right? After that, we're going to have equation 1 multiplied by delta v by delta y. So let's see what happens. Delta v by delta y multiply delta u. So delta u and delta v by delta y del y, change in y, alright, is equal to, okay, no, change in x, I mean, going to be delta v, oh no, delta v by delta y will multiply, oh, there's no change here, oh yeah, mixing up myself, yeah, delta v by delta y multiplied by change in u, equal, alright, time for this one now, delta v by delta y will multiply all of this here, so delta v by delta y times delta u by delta x times change in x plus delta v by delta y times all of this now. So delta v by delta y times delta u by delta y change in y. Alright. So we have the two new equations now. Call this equation 3 and this equation 4. And then we say equation 3 minus equation 4. Equation 3 minus equation 4. What's going to happen here now? When we do this, we have delta v by delta u, del v times delta u by delta y minus del u times delta v by delta y equals, alright, this part we have all of this minus all of this, so it's delta v by delta x, delta u by delta y, which is this, right? Oh, del x, right? Minus this one now, delta v by delta y, delta u by delta x, changing x. Alright, so we have that. Plus now, plus what? Now what happened here? All of this. Delta v by delta y, delta u by delta y, del y, minus this now, delta v by delta y, delta u by delta y, del y. Let's put them together now. You have del v times delta u by delta y minus del u, changing u, times delta v by delta y equals. Now you see this, we're going to factor out the del x, open bracket, delta v by delta x, delta u by delta y minus delta v by delta y, delta u by delta x. Now what happened out here? You have delta v by delta y, same thing here, delta u by delta y, delta u by delta y, del y, del y. It's the same thing. So it cancels. This is gone. You see that? Now we're going to divide both sides by this part in the bracket. Let's put this delta x, del x out here. This change in x equals, is equal to what now? It's going to be this, which is change in v, delta u by delta y minus change, small change in u, delta v by delta y, all over what now? Going to be delta u, delta v by delta x, delta u by delta y minus delta v by delta y, delta u by delta x. Alright, so that is del x. It is delta u by delta y times delta u by delta y times a small change in v minus delta v by delta y, small change in u, over all of this. But this can also be written. Let's write it in two ways. It can also be written. If you multiply both top and bottom by -1, you have this negative change to positive. So it's delta u times, it's del u times delta v by delta y. So it's small change in u, delta v by delta y, minus small change in v times delta u by delta y. So that's delta u by delta y all over. This will switch around and this will become delta v by delta y, delta u by delta x minus delta v by delta x, delta u by delta y. Alright? So that's what we have. Now, here, let me just copy this part here. Wait, something else is being copied with it. What's going on? What is this? There's nothing there. Let's copy and drag this thing down here. So this is delta x, or del x. A small change in x is equal to this. Let's combine this thing, make a copy and bring it up here. Where is it? Didn't I just copy it a while ago? What's going on? Where did it go? Oh boy. Let's make another copy of it and move it, because I don't know what happened to that one. Just disappeared like that. Oh, that's it, you know. It's there, it's there. It's the same thing. Alright. So let's move it up here. Alright. So we have small change in x and small change in y as well. Alright. You notice the denominators. Let's rewrite the denominators. Make them look the same. U first, delta u by delta x delta v by delta y minus delta u by delta y delta v by delta x. This is what I just wrote down. Let's rewrite this now. Let's put the delta u by delta x first and the delta v by delta y second. Delta u by delta x, which is this part, and then this part after, delta v by delta y minus this part, delta v by delta x, delta v by delta x, time delta u by delta y now. Delta u by delta y. You notice the denominators are the same. Now, this itself can be written as a determinant, a 2 by 2 determinant. Let's see what it would be. Now remember, you find a 2 by 2 determinant. The vertical lines, so that is determinant. I have A, B, C, D, and the determinant is equal to, well, I don't need to write DET again because the vertical line shows it's a determinant. It is AD minus BC. This time this minus this time, alright? Now, this, you can write this now as delta u by delta x times delta v by delta y. So you have the AD minus and then this part now, the BC. So this is delta v by delta x. Now, and the x is lined up in the first column and then the y is in the second column. Delta v by delta x and delta u by delta y. Now this is this determinant here is called the Jacobian. Alright? So that's the Jacobian. Now here, what you can write, if you rewrite these, then del y is equal to or del x. So let's write del x first, right? Del x is equal to, well, del x in this case would be delta v by delta y times a small change in u minus delta u by delta y times a small change in v over the Jacobian j. Alright? And then delta y now, del y would be equal to delta u by delta x, del v is delta u by delta x del v. Let me separate them, I write them too close, minus delta v by delta x del u, delta v by delta x del u. Alright? So here, let me just put them in boxes to separate them. Here you have del x and del y. See that? Now, let's consider something. Suppose you hold v constant, right? If v constant, if V is constant, then the change in V would be 0 because it's constant. There will be no change. So what you would have, oh, I have this here. Let me get it out of the way. What would happen if you hold V constant is that this part will become 0 because delta U by delta Y times delta V will become delta U by delta Y times 0. So the change in X would be delta V by delta Y times change in U over the Jacobian. Alright? So you see that? And if you divide by a change in U, then what would happen? If you divide by change in U, then what would happen is that change in X divided by change in U would become delta V by delta U. It looks like 6. Let me rewrite it. Oh, should be this. Delta V by delta U over the Jacobian. Right? So, if you make the changes approach 0, then what you'll have is dx by du. Oh, no. I'm mixing up myself. It doesn't approach 0. It's a partial derivative. Delta u, delta x by delta u would be that. Now remember, just as in the previous examples, at first we found delta u by delta x, and then we went through the long process of finding delta x by delta u. But if you know the Jacobian, just put delta v by delta u over the Jacobian and you get this. Alright? So we have delta x by delta u is equal to delta v by delta y over the Jacobian. Now, here, you hold v constant. What would happen in the case of del y? What would happen? Well, if you hold v constant, change in y would be, this part would be 0 because change in v would be 0. So you have negative delta v by delta x times del u over the Jacobian. If you divide by del u now, it's over del u, they would cancel. So the del u part would go, and this would be under del u, right? Oh, I missed something earlier. Yeah, the del, this should have been del, you know. Yeah, this is del, right? I just remember. But here, as delta u approach, as del u approach 0, the change in u approach 0, you have delta x by delta u. Delta x by delta u would be delta v by delta y. Oh, delta, I had u here, delta v by delta u. This was, let me redo this part. Delta v goes to 0. So this is delta v, delta x is equal to delta v by delta y. This would have been y, not u. My. This was y. Gosh. Delta v This was delta V by delta Y, right? This is Y. So this is delta V by delta Y, right? Because before delta V by delta Y. That's what it should have been. I tell you. So it's delta U times delta V by delta Y minus delta V, del U, changing U times delta V by delta Y minus changing V times delta U by delta Y over the Jacobian, right? So this goes to 0. This becomes del X would be del V by del Y and delta U. When you divide by del U, you have, right, del X by del U is equal to del V by del Y over the Jacobian, right? So del X by del U is del V by del Y over the Jacobian, right? That's what it should be. And then as del U approaches 0, the del changes to delta. So delta X by delta U would be equal to delta V by delta Y over the Jacobian. I'll list out the Jacobian here. Right. So delta X by delta U equals delta V by delta Y over the Jacobian. Alright. Let's look at the case with the change in Y. So the change in Y, let's start it over again. V is constant, so the change in V is constant. So the change in Y is equal to change in V. This will become 0, so that part is 0. So we have negative delta V by delta X, changing the partial of V with respect to X times change in U divided by the Jacobian. We divide both sides by changing U. This would cancel. So the change in U goes from the right. What we would have here is delta U by delta Y by delta U equal minus, or del Y by del U equals negative. And remember, this is U. Right. Del Y by del U equals negative delta V by delta X over the Jacobian. Now, as the change in U approaches 0, tends to 0, then this becomes delta Y, become derivative delta Y by delta U is equal to negative delta V by delta X over the Jacobian, alright? So delta Y by delta U is equal to negative delta V by delta X over the Jacobian. Now, we have these results here. Let me put this one beside this. Now, what will happen if it is delta U that approaches 0? That if U is a constant. Let's see. Now, U is held constant, so the change in U equals 0. This would be 0, so the change in X equal negative delta U by delta Y times the change in V. If you divide both sides by O over the Jacobian, right? If you divide both sides by change in V, by change in V, change in V cancels change in V. So that part goes. And then here, as the change in V tends to 0, then what you have is partial derivative of x with respect to V is equal to negative partial derivative of u with respect to y over the Jacobian. Alright? So we have delta x by delta v is equal to negative delta u by delta y over the Jacobian. Better write this y properly so that I don't mix it up and think it's u. So we have this result now. Let's put it down here. Alright. And then what would happen with in the case of the change in y? Change in y is equal to del u is 0, so this part will go to 0. So delta u by delta x change in v over the Jacobian. Now if we divide both sides by a change in v, what will happen here is that this is what we would get. Now as the change in v tends to 0, then you have delta y by delta v is equal to delta u by delta x over and divided by the Jacobian. So delta y by delta v equals delta u by delta x over the Jacobian divided by the Jacobian. So let's move this result here. So these are the results that we have here, right? So here now, I have delta v by delta y, I have delta x by delta u. Now, remember here that in the previous example, what we had found while we were working out was delta u by delta x. Then later on we found the inverse, delta x by delta u, right? The inverses are the delta x by delta u, which we have here, delta y by delta u, which we have here. We have delta x by delta v, which we have here. We have delta y by delta v, which we have here. Alright? So you see that. So these are the various inverse derivative that we found. So that's it for now. I will see you in the next video.